Suppose we have a function f of x that is continuous, positive, decreasing on the interval 1 to infinity, and we let the term a sub n equal to the function f of n. Then the series a sub n is convergent if and only if the improper integral of the continuous function f of x from 1 to infinity is also convergent. Notice that the function f of x is the continuous version of f of n. There are two cases. One, if the improper integral is convergent, then the series a sub n is also convergent. Case number 2. If the improper integral is divergent, then the series is also divergent. To see this, we can represent the series on the graph. We graph each of the terms below the continuous functions. Then the sum a sub 2 all the way to a sub n is less than the integral from 1 to infinity of f of x dx. If this integral is convergent, that means it is a finite number, then the sum is also a finite number, and if we add the first term a sub 1 to this finite number, the series is still convergent. If the integral is divergent, then we represent the terms above the continuous function f of x. The sum a sub 1 all the way to a sub n is more than the integral, but the integral is either infinity or it is not a finite number, then the sum is also infinity or not a finite number. Therefore, the series diverges as well. What this means for us is that we're going to use the conversion of the integral to determine the conversion of the series. And we can do this if we can express a sub n as f of n, where the terms are positive, at least at some point n. The function f of x has to be a continuous, positive, and decreasing on the interval 1 to infinity. For example, consider the harmonic series, the sum of 1 over n, as n go from 1 to infinity. The a sub n terms is 1 over n, which can be written as the function f of n. Since n is greater than or equal to 1, all the terms are positive. F of x is 1 over x. We see that this function is a continuous, positive, and is also decreasing. It is decreasing because the first derivative is negative 1 over x squared, which is negative, and so if the derivative is negative, then the function is decreasing. Now we integrate 1 over x from 1 to infinity, but this is the improper integral. We evaluate this improper integral using the fundamental theorem of calculus. The antiderivative of 1 over x is ln of x. We then plug in t and 1. ln of 1 is 0. ln of t go to infinity as t go to infinity. The integral diverges, so by the integral test, the harmonic series is also divergent.